We want to talk about the domain of an expression some more. And once again, to review briefly, there's really two times when we have to be concerned about the domain. And the two times are, so once again, we're talking about domain here. And the two times to be concerned are when you have variables in the denominator of a fraction. And what's the concern there? We have to make sure that we never end up with a zero in the denominator of a fraction. And now the second concern is no negatives under a square root. So those are really the only two times you have to be worried about the domain. Normally the domain is all real numbers, but if you ever have variables in the denominator of a fraction, then you have to worry about some values that are not in the domain. And if you have a square root, then you have, and if you have a variable inside the square root, you have to make sure that the expression under the square root is never negative. So let's look at a function that sort of has some interesting aspects to it. F of x equals square root of 4x minus 3 over x squared minus 4. Now the reason why this is an interesting expression is I have both situations where I need to be concerned about the domain. The numerator, I have a square root, so I have to make sure that the expression under the square root is always greater than or equal to 0. And then I also have variables in the denominator, so then I have to also worry about the values of x that would cause that denominator to be 0. So really I have both concerns in the same problem. So let's just handle them one at a time. Let's first look at the square root and see what the domain would be for the square root. So the key is I have to make sure that 4x minus 3 is greater than or equal to 0. I have to make sure it's positive or equal to 0. So I take this and I'm going to solve this thing for x. So I'll add 3 to both sides and then divide both sides by 4. So I have x greater than equal to 3/4. I'm going to go ahead and graph that on the number line just to make it very clear. So far, if I look at my domain, here's 3/4. I'm saying x has to be greater than or equal to 3/4. So far, this interval would be my domain. But I'm not done. Normally at this point, if I didn't have the denominator, I would just say the domain is from 3/4 to infinity. But you know what? I have to go check the denominator. There may be some values in this domain that will cause the denominator to be 0. As a matter of fact, I need to go ahead and factor the denominator. This is the difference of squares, x plus 2, x minus 2. So from looking at the denominator, I know that x cannot be equal to 2 or minus 2. Because if x is equal to 2 or minus 2, then the denominator is 0 and my number blows up. So from the square root, I'm sitting here with my domain being greater than or equal to 3/4. And then I go over here and I see, if I graph minus 2 is somewhere right here. Well, minus 2 is not even in the current domain. This minus 2 comes from the denominator. But how about the 2? The 2 is right there. that 2 is currently in the domain. I've got to take it out. So you know what I really have to do? Let me redraw the number line. So here's 0, here's 1, here's 2. From the square root part, I go to 3/4. However, I know 2, I cannot include 2. So I know I can go from 3/4 to 2. I have to skip 2. 2 is not in my domain because the value of 2 would cause the denominator to be 0. So I skip 2, so I put sort of back-to-back parentheses and then continue the interval. So it's almost like the domain is going to be my original domain from the square root, except for the value of 2. And that happens because a 2 would cause my denominator to be 0. So now I can write the domain. It starts at 3/4, and it goes to 2, but does not include 2, so I put a parenthesis. And I'm going to union it now with this other interval, which picks up at 2, but does not include 2. That's why it's parenthesis. And then it goes on to infinity. So what's really going on is I find my original domain from the square root portion, and then it's like I go look in that domain and see if there are any numbers that are going to cause the denominator to be 0. And then I have to exclude them. And for this case, I found that 2 was going to be a problem, so I had to go down here and take out the 2, and now write my domain as this.